the last few videos, we worked on limits for polynomial and rational functions. Now it's time to explore how different limits behave for trigonometric functions. But don't worry, these limits aren't much different from what we've already covered. Let's start with the basics, cosine and sine. These two limits behave just like regular functions when you take limits. In fact, if you're trying to find the limit of either sine of x or cosine of x as x approaches any number, you can almost always just use direct substitution. For example, let's try finding the limit of sine of x as x approaches pi over 4. Using direct substitution, we get sine of pi over 4, which is square root of 2 over 2. Simple, right? Similarly, if we want to find the limit of cosine of x as x approaches pi, we just substitute and get cosine of pi is equal to -1. And so, again, you can see it's very straightforward. But now let's talk about functions like tangent, cotangent, secant, and cosecant. These functions are a little bit trickier because they have asymptotes, places where the function shoots off to infinity or negative infinity. For instance, take the limit of tangent of x as x approaches pi over 2. If you try plugging in pi over 2, you'll notice that it isn't defined, and that's because it has an asymptote at pi over 2. So the two-way limit literally doesn't exist. We'll cover these types of limits more detail in another video, but just remember when dealing with tangent, cotangent, secant, or cosecant, things get a little bit iffy. Now that we've covered easier limits, let's move on to two special trigonometric limits that are super important. These limits will come up a lot, so it's important to get them down. Both of them are on screen here. Notice that if you use direct substitution as we talked about before, you'll get 0 over 0. While the proofs are a little bit complicated to get the solutions, if we look at the graphs here, we can see that they do in fact approach 1 and 0 respectively. Let's try an example using one of these limits. Say that you need to find the limit of sine of 3x over x as x approaches 0. Notice that if we try plugging in 0, we get 0 over 0, so we can't use direct substitution here. But we do notice that we can rewrite the expression like this. Now, if you substitute in another variable for 3x, like you realize that what we have here is the same special limit as what we just saw. That means we could substitute 1 into sine of 3x over 3x, and we get our answer of 3. Now it's your turn, so here are a few practice problems. Pause the video and try solving them using direct substitution or the two special trigonometric limits we just discussed. Alright, and here are the solutions. That's it for this video. If you have any questions, feel free to email me at lowqualitymathematics, and let's do some more math in the next video. See ya!